Hi, this is Mrs. Urano. I'm here to work through this word problem together with you using the strategy of modeling. We're not going to use a bunch of variables and algebraic calculations. We're going to draw pictures of it and actually model what's happening. So the question says, there were a total of 840 guests at a wedding dinner. 60% of them were adults, and the rest were children. So right away, I'm just going to write really quickly the rest. That must be 40%. 60% and 40% make a total. Some boys left before the dessert was served. First of all, I don't know what they were thinking. But next, let's see. As a result of some boys leaving, so boys are children, right? Therefore, since some children left, the percentage of adults increased. That makes sense, to 70%. So how many boys left before the dessert was served? So how many left is the question. So let's take a look. I'm going to draw a box to be 840. I can make it really big. So this is 840 guests. And draw that. 840 guests. I'm sorry, I'll be a little more specific from there into here. Okay. So some of them were adults and some were children. So 60% were adults. I can eyeball that this is like 50%, so 60% is probably somewhere around here. But I'm actually going to make it pretty exact. I'm going to go ahead, since we're talking about 60%, that's 6/10. It's also 3/5. I'm going to divide this into tenths. So I'm going to do, there's 5/10 there, 2, 3, 4, and there's 5/10 there. So these are going to be equal units here, and each of these units are 10%. I could write that on each one, but I won't. And hey, 10% of 840 is 84. So each of these units is 84 people. Okay. So 10 groups of 84 people are 840 guests altogether. All right. And let's see. Again, it says 60% were adults. So this is 10%. This is 20, 30, 40, 50, 60%. So I'm going to label these as adults. And these as the children. 60% adults, 40% children. Okay. So what now? Some boys left, and as a result, things were different. So I'm going to label this as before they left. And then after they left, things were a little different. I'm going to make this line up right here. And then over here, it's not going to be as long because some boys left. So it's going to be a bit shorter. I read that line a bit low. Oops. All right. So now this is how many guests there were after. There were fewer guests. And this right here then would be the number of boys that left. We don't know what this is. So this is our question mark. Every time we model, we want to have there be a question mark. So this is what we don't know. This is what we're trying to find. It's always good to put a question mark on our model. Okay. Now, as a result, the percentage of adults increased. So the number of adults is not changing. There's only kids that left. So I'm going to make a big fatty line right here. The number of adults, the key is to realize the number of adults is still the same. However many there were here are still here. They didn't leave before dessert. Only some of the kids did. So how many boys left? So this is our question. How many adults are here? We actually know that. There's 6 84s here. So 6 times 84 is, 6 times 4 is 24, carry the 2. 6 times 8 is 48, times plus 2 is 50. So 504 adults. Another way to write this is it says that 60%, so we can write 60% of the total guests, 840. And if you actually did that calculation, you'd also get the same answer, that there's 504 adults. Either way works. This way, I like a little bit more with the modeling. It might be a little bit more strange, but good to get used to. Anyway, and 84 times 4 is going to be the number of children that are left. I can also calculate by knowing if there's this many guests all together. I can just subtract the number of adults to get the number of kids. It should get you the same answer. But really quick. Okay, so there's 336 children, and there's 504 adults. Now again, there are still going to be 504 adults here because none of them left. And there's going to be a fewer number of children because some of them left. Okay, what else can we do now? If you ever get stuck, always go back to, is there any information that was given that I haven't used in my model yet? So again, I see the 70%, I've not used that number yet. It says, as a result, the percentage of adults is increased to 70%. So this many adults is actually now 70%. I'm going to write as a percentage. So this number of kids must be 30% then. Okay. But wait a minute. I know that 504 adults is 70%. So I can go ahead and do some calculation with that. What I'll do actually is divide this whole box now into groups of 10, into little 10% groups. So this is 70%. I'm going to make sure there's 7 boxes here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. All right, so that's 70%. Each one of these is 10%. And we need 3 10% here. Okay? And how much is each one of these boxes? Well, there's 7 of them. This is another way to kind of think of doing this calculation. There's 504 altogether, but now there's 7 boxes. So let's divide that by 7. Then we'll know the size of one of these boxes. 7 times 7 is 49. And 7 times 2 is 14. So each of these boxes is now 72. Let me be clear in my writing so I can read it. All right, so now what do I do next? Well, let's go back to what am I trying to solve for? What's my question mark? My question mark is how many kids left? What's this number here? And wait a minute, if this is 372s here, that means that there are now 216 children. So if there were 336